Hey everyone, we're just gonna wait to get everybody in here. Can everybody hear me? Yeah, good. Okay. Happy Tuesday. Thank you for the thumbs up, Colton. That helps. Hi, Dakota, Olivia, Misty, Chris, Mark. Everyone's joining on. So we got 20 people on. We'll give it a couple more seconds here. How's everybody doing? Have you had a good first week? We're on to week number 2. So you survived the first week. Congratulations. I think I've gotten some of y'all's already your diagrams. So thank you for doing that and just keep them coming. I've only gotten one of 30 of you guys giving me what you guys are going to be writing your journal articles about or journal summaries about. So please get that to me as soon as you can. Doesn't have to be anything too crazy, just narrow it down. Patrick, Chloe, Victor, guys, good to see you. Going through everyone here. So let's just do some housekeeping to start. So did everybody see the diagrams in the content section, correct? You're able to download those. Usually people, what they do is if we do it digitally, you just insert like a little text box over, or you just print them out or write it, shoot me a pic and email it to me. I am having you email it just so that I can give you that feedback. It's a little bit quicker. And I can be like, awesome job, 100%, way to go. Or maybe rethink a few of these structures and get it back to me. That way it gives you a chance to get familiar with anatomy. And it's not like okay, you failed this assignment. I want you guys to actually know what you're talking about whenever you're looking at these structures. So let me get this all going. Couple more people in already, great. So you got your diagrams, you know what you're doing there, great. If you guys have your journal topics, because remember we're doing those 5 journal summaries, and then all those summaries are going to culminate and create a beautiful research paper at the very, very end. Please give me that topic. That way you guys can start looking for your articles. That way you're not racing around at the last minute to get those done. Not saying that you're going to procrastinate, but I've been there. So I'm not saying that you will, but there's a 95.5% chance that you might do it. So trying to save you guys some heartache. Let's see here. All right. Any other questions that we have about the current stuff that has been assigned? I mean, you only got one thing so far, nothing too crazy. Does everybody feel confident with last week's material? So I know that we kind of talked about the different planes and axes, and sometimes that can throw people for a loop. Were you able to click on the YouTube links that I included? Did that help you guys out? If it did, tell me in the chat box. Type yes, type no. I have no idea what we were talking about. That works too. As we go through here, I will try to hook you guys up with several different YouTube links, especially from today. Whenever we talk about ossification, there's 2 different types that we're going to be breaking down. And sometimes it's good to see it because I can only explain it so much over video this way versus they have some great animations that I want you guys to see. So be looking for that from me. I'll probably email it to you because I have several that I like. All right. So without further ado, if anybody has any questions, please let me know. Let's go ahead and get into the good stuff today, shall we? So I'm going to share my screen with you, talking about bone development here. Sorry. As I was reviewing today, because actually I'm teaching the same sort of topic to my human anatomy course. Granted, we're not going into the specifics that we're going into today, but it kind of goes right in line. Luckily here we get to park on skeletal tissues, which is my favorite. But in the other classes, we're also breaking down the different other tissues that the body has. So we'll have fun today and try to make it applicable as well as just get the anatomy. I mean, we're going to have to discuss some terms, so it might get us hair boring as we read the slides, but hopefully we'll give you some good stuff along the way too. So bear with me. If you have any questions as we go through, please, 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 please put it in the chat box or use that little like hand wave. They have different emojis there that you can use. I should be able to see that over here on my right. So just let me know. All right, so connective tissues, let's just dive right in. So it's the most widespread tissue in the body, obviously, because it's everywhere. We gotta have it. It encloses, separates, supports, causes movement, protection, transport, cushions, insulates, and then stores. So if you think about connective tissue, and as we break down the different types of connective tissue, you will see why it has so many different functions. And it's so necessary for life. Now, some different properties that we need to consider. This will not be the only time that you hear someone talk about Wolff's Law, especially if you're going into the profession of PT, chiro, strength, AT, whatever the case might be, you are going to see this. So Wolff's Law, just the basic definition, tissues will respond to the stresses placed onto them. So if you think about it, whenever you work out, usually there's that period. Usually it's the first couple weeks, right? Say you took a couple of months off, you kind of slacked over COVID, and then you were like, okay, I'm gonna hit the gym, I'm gonna get back at it. And those first few weeks, how many of us were like, I can't walk now? Like after the first couple sessions, you're like, my legs hurt, my butt hurts, my arms hurt, I can't do my hair. That's because your tissues were responding in kind to the stresses that you were placing on them. They were getting stronger, they were breaking down the tissues, you were rebuilding the tissues during your rest, and bam, they are responding to that stress applied. Now, whenever we talk about this, we need to know the properties of these connective tissues. So stretch, the ability of a tissue to lengthen without damage. So whenever we talk about stretching, you know, we think yoga. We think, okay, I have to hinge at the waist, forward fold, touch my toes, right? The body is naturally, the muscles are naturally supposed to be able to stretch and return back without any damage placed on them. What we see is whenever people maybe with a little bit too rough of a stretch, or maybe some sort of genetic disorder or condition like a hypermobility, that's whenever you can sometimes get that stretch and injury cycle going. But stretching, it happens. It is a good thing. You need to have it. You need to have those tissues nice and pliable and be able to lengthen and contract. So elasticity, the ability of the tissue to lengthen and then return back to its original length. So this is what I was talking about. It gets that stretch. But just like a rubber band, you're being able to stretch it and then it just recoils right back in. Contractibility, so I can't talk tonight, excuse me guys. Contractility, so whenever we talk about the ability of the tissue to shorten via contraction, it should be able to contract. Your muscles should not just hang out there. You should have the nervous system wiring to your muscles, that neuromuscular connection to be able to flex your muscles and contract. That is important. So just like we want it to relax, we want it to contract. So I'm adding more people here. And now it messes with my slide. Excuse me. We froze. Can everybody see that? Is it just me? Give me a second. I think it's because I added a bunch of people. Yay, technology. We love it, right? I'm just gonna say that every time so that I don't like throw something. Okay. All right, so let's just break this down a little bit more. So plasticity, the ability of a tissue to mold to another shape, then it returns to its original form. I always think about cats, right? Like, have you ever seen what cats can fit in? I mean, holy crap, they can just go into a box that you're thinking there's no way, or a tube, or a bowl, like a fish bowl, and you see them curl up in there and then they plop back out and it's a cat. That's the type of thing that I want you to think about whenever you think about plasticity. It's able to mold to another shape and then return to its original form. Creep. So creep is a state of becoming elongated and deformed due to the loads applied over time. I always think about hair ties. Ladies, you know what I'm talking about this. Maybe gentlemen, maybe you know what I'm talking about this. Maybe your girlfriends or whatnot have one. But you have those hair ties that you have around your wrist, and whenever you use them too much, or you stretch it out just a little bit too much, it doesn't go back the way that it was. And so you're stretching it, and yeah, used to, it go right back. But then after time, if it's deformed or it's held at that extreme state for a while, it doesn't really spring back like it used to. So creep. So far we've covered 5 different properties. Now let's talk about any questions over that. So again, we talked about the 5 different properties. Any questions? So we have stretch, creep, plasticity.
I have a question.
Yes, ma'am.
Can you give an example of plasticity and creep, like human wise?
Yeah. Yes. So whenever we're looking at, so look right here. Creep. This is a good example. I usually use the non-human examples because people can't visualize it yet, especially if you don't have anatomy. But Misty, you got this. So think about, see that lumbar vertebrae and then into S2, S1 at the very, very base. Everybody see that? They're right here. Yeah. So over periods of time, sometimes we can have tissues that start to, because of an inoptimal load has been placed on those tissues, they can start to, I don't want to say deform, but adapt to their surroundings. Does that make sense, Misty? So say I have a person in front of me who, if you guys can see me, hopefully you can, they walk like this. And so you can look at them and their alignment's not quite right. Like one strength is above, sorry, I'm getting a bunch of stuff over here. You see one shoulder above, all sorts of stuff, and you just see how it's kind of wonky down the spine. Well, that wonky down the spine, that malalignment, can actually start to create a creep or deformity within the tissues. And so creep is just this long-term effect of misalignment or malalignment in the tissues. So think about somebody who hasn't gone to the chiropractor in a while, who needed to go to the chiropractor, or see a physical therapist, have some body tissue work done, and then they reap the benefits later on whenever they see their x-rays or whatnot and they see the response in the tissues.
So would it be like an imbalance, like a muscle imbalance, like shoulder?
Yes. Yeah, but it's usually seen a lot in even your slip discs, which we'll discuss later why I'm air quoting this, but that's the common term, right? Where maybe a vertebra itself or the disc itself has started to creep out because of that malalignment. Does that make sense? So say if your spine is, instead of being straight up and down with that beautiful S curve that we will talk about later, instead there's like a little bit of a shift. That slowly cause this stretch and this shortening to creep and let that disc come out the side and creep outwards, and then we have that bulging disc. Does that make sense? I will break a lot more of this down later and a little bit more, because whenever we get to the spine, we actually get to diagnose and talk about those different diagnoses that happen, like spinalolysis, spinoplesis, things of that nature. But you're exactly right. It's kind of the marriage of the two, because you can't really have one without the other. Usually whenever you have malalignment or misalignment in the spine, there's going to be issues in the muscles as well. Does that make sense, ma'am? Okay. Sorry, I'm catching up on some chat stuff. No worries, Emily, you're good. All right, so let's talk about plasticity. So whenever you think about here, I want you to think about Oh, let's see here. I'm trying to think of another one that's not spine related because usually I go to the spine. Nope, we're just going to go to the spine. So let's talk about, say you have a vertebral disc and you have a misaligned spine, like we were just talking about. And so you have that creep that's occurring and you have a disc that is starting to protrude out. And we will talk more about that in the different stressors and the different classifications and stages of a disc herniation and lack thereof. But you'll start to notice that the disc itself actually starts to change shape. A lot of people, they start freaking out whenever that happens. They don't know that actually you can realign things, and I don't want to say fix your herniated disc, but you can re-optimize it and it can start to change its shape back to its original form. It's only whenever we get way further along and that disc actually, I don't want to say explodes, but it has a protrusion out, that we have really bad issues, and that's where we get to have surgery. But there is chances, and there are a lot of circumstances where people have that disc start to creep out and that plasticity change occurs within that disc. But whenever we get realigned and we work on our strength, our flexibility, the tissues around, and alignment, you'll actually see that disc go back to its original form. And I'm sure later on, another muscle or another structure in the human body will pop into my mind, and I'll be sure to send you an email, Misty, but that's a good one because everybody knows the discs in the spine. Does that make sense, ma'am? Okay. Any other questions? Great question. And all of that will be really fun whenever we get into the spine itself, because we will go through those classifications and we'll chat about it. So, all right, let's make sure as we go through here. Okay, so everybody, has anybody not heard of extracellular matrix? Probably those of you who have not taken anatomy, you're like, what is that? So the extracellular matrix is comprised of, it's a bunch of just goop. I want to say goop, but that's not the technical term. It's ground substance and proteins. These proteins are collagen, reticular tissue, and elastin. These components help give us the fluidity. It helps gives us a bunch of strength and so much more. And these proteins, especially you see collagen, that's a buzzword right now because a lot of people, they want to take collagen supplements. Some people, they think, oh, we already got it. We don't need any more. But there's science behind the fact that yes, a lot of us, because of our diet, we actually need to supplement our body with some additional collagen. It's not like you guys are eating bone marrow for dinner anymore. So we gotta sometimes get it from those places. Now collagen is tough and strong, occurs in bundles. Reticular tissue is more delicate and occurs in a network. And elastin is elastic. It's kind of more that coily shape that link together. We'll chat more about that. And especially if you go into a human anatomy course, we really dive in and look at these structures. So ground substance, has anybody, I'm gonna skip down to glucosamine conjoint. Has anybody heard of, taken, or just anybody? Maybe, yeah. And then also the hyaluronic acid is another one that people hear. Yeah, see some shaking heads. So ground substance is a part of that ACM for short, extracellular matrix, and it helps provide the cush in our joints. And so a lot of times you hear doctors or you see people like myself, a women's health athletic trainer or PT, they will say, hey, you would really benefit from taking glucosamine conjoint. And then sometimes they'll also add in that hyaluronic acid. There's actually supplements that combine all that together, which is great. And they give it to you, especially if you have any creaky joints as you age, or if you have had any injuries. What this does is it actually helps to bring the fluid back into that space, for lack of a better term, because we need that, that fluid within the joint space in order to properly lubricate the joint. So GNC, it actually traps large quantities of water and thereby permit tissue to some degree to be able to give it a little bit more elasticity and plasticity. So what that means for us especially if we're going into a healthcare field, is that if we start to see that a joint is more compressed, or maybe it's a little bit more creaky, or we have a lot of pops, or we have a lot of just grinding, maybe there's a lack of fluid therein. And so that's where you start to see that elasticity and plasticity, so we want to give it a little bit more help. So whenever you take those supplements, it's basically trapping those quantities of water and trying to bring it into the spaces that need it. I love to put a little asterisk sign right here. If you're going to use this product, you need to drink extra water. I wish I could scream that at the top of my lungs. But a lot of people, they're like, okay, great, I'll pop this pill. It'll help me get better. It'll help my knees to stop hurt. Awesome, I'm back to running. And they forget the key component that our body uses water for so many different things. We need to ingest just a little bit more if we're going to be trapping more of it and giving it a substance that's purposely going to be trapping more of it and helping us out with this elasticity and plasticity. Any questions on that? Okay. So we're going to go over a few cells. Again, I'm not going to dive deep into it just because I will leave that for your anatomy professor later on. But we do want to have some sort of grounding for some words that we're going to see maybe later on. The names are named by, the cells are named by the cell specialty. So if you start thinking and looking at the parts of the word, both the prefix and the suffix, then you will know what's going on in the word. So let's look at osteo, means bone. Makes sense, right? We've heard that. Maybe you haven't, maybe you have. Chondro means cartilage. Fibro is a fibrous tissue. Suffix will tell you the cell function. So blast, create and lay down. Class, break down the old. And sites are mature blasts surrounded by the matrix. So whenever we start piecing these together, we have osteoblasts. What's that going to do? What is that? It's a marriage of bone, and it's a type of cell. So it's a bone cell that creates and lays down new tissue. So osteoblast, it's laying down that foundation. Then what if we did osteoclast? It's breaking it down, taking away that damaged tissue. So if you get these little prefixes and suffixes into your vocabulary and kind of know those, it's a good starting point and you're a little bit less lost whenever you venture into the world of medical terminology. Does that make sense to everybody? And this will go across the board. It doesn't have to just be in my class. You'll see this a lot. And if you can try to piece out the words, it'll really help you just understand what the full concept is. And especially whenever you get into cells, you'll understand that whenever you're talking about squamous epithelium or cuboidal, things of that nature. Maybe you have heard these words, maybe you haven't. But once you understand the definition of each, you're able to better partner them as a whole. Any questions about cells? Okay, so let's talk about cellular names. So as we talked about, osteocyte means a bone cell. Chondrocyte is a cartilage cell. Fibroblast breaks down fibrin clots and creates new ECM and collagen structures. So whenever you break it down, fibroblast, right? Makes sense. This is great for wound healing and whenever you're trying to get that wound to kind of contract and heal over, you really need those fibroblasts to come in. You'll hear more about that whenever we talk about wounds, don't worry. Osteoblasts, so that's where the cell actually lays down new bone tissue, and we'll talk about that here in a second as well. Point of interest, because there are very few cells in connective tissues and a very high quantity of ECM and ground substance, the ECM and ground substance directly determines the tissue type. What in the world does that mean? What that means is whenever you have more things in a room, does it feel more cluttered and not as flexible and not as pliable as if you walked into a room and you just clean it and everything's put away and looks all nice and neat and you walk into the room and it's like, this is nice and clean. I can do stuff with this, right? I'm moving. So I'm thinking about all the boxes of my living room right now and how I walk in there and I have many like anxiety attack because I'm like, what do I do with this? Versus I walk into our new house that we're working on right now and everything's bare. And I'm like, oh my goodness, there's so much that I can create and do with this space. The same thing happens within our cells and the tissues that correlate. Whenever you have a lot of stuff jammed in there and it's very dense, you're not going to get as much flexibility, not as much movement in that tissue. As whereas if you have a lot of that extracellular matrix versus all the cell parts and stuff, you're able to spread out a little bit more. You're able to do a little bit more because there's a lot more fluidity within that space. So let's apply that to the human body. Say a tendon. Do you want a tendon which connects, we'll learn here in a second, muscle to bone? Do you want that to have very much elasticity or flexibility, should I say? Let's talk about flexibility. So think about your Achilles tendon. Do you want that guy to be able to stretch a lot? Do you want it to be able to move a lot? Or do you want it to be a nice thick anchor that anchors your calf muscle, which has a lot of stretch, to your heel? Yeah, start to think about it that way. So a lot of space, a lot of room. I just walked into my fresh open room is our big juicy calf muscle that has a lot of fluid in it and can stretch and can move and do all these things. Versus the tendon, which is my cramped living room full of boxes, it's not going to be able to move around as much. And really we don't want it to because we want something that's strong and can pin our muscle to the bone. Does that make sense? Clear as mud? Any questions in regards to that? You guys will hear a lot of painting analogies and moving and analogies here. We're doing a lot of construction, so there might be a little bit of that too. All right, any questions? Please let me know. All righty, so let's talk about the types of connective tissue. So we're going to talk about connective tissue as far as adipose tissue specifically. Does anybody know what adipose tissue is? You do? Tell me.
Fat tissue.
Yeah. Yes. Yes, ladies, you're exactly right. Remember how I mentioned that connective tissue was responsible for a whole list of functions, and one of them was insulation? That would be our adipose tissue. It's there to insulate us. Not all adipose tissue is bad. Dense regular connective tissue, we are going to cover that. It's going to be talking about the tendons, ligaments, bones, cartilage, blood. Now, the dense irregular connective, we're not going to talk about. You are going to cover that more in your human anatomy. So that's going to be more of the arterial walls. Okay, so we're not really going to touch on that very much here. Okay. So let's talk about loose connective. Protein fiber, it's a protein fiber network with fluid-filled spaces designed specifically for loose packing, support, nourishment, and temperature control. So what does that sound like? That sounds like fat, right? It's a temperature control. It nourishes us because it helps to store certain things for our body. And it's loosely packed, right? Another thing that we should be thinking about, but we typically don't whenever we see this definition, is fascia. The fascia in our body, it gives us a lot of support. It's a loose packed tissue. It has a bunch of nourishment in there, and it actually does help with temperature control. Maybe not so much as fat, but it does. The biggest thing that people connect fascia with is plantar fascia in the sole of your foot right here. You see how it has that big red like ouchie right here? And then you have the lovely foam roller, AKA your rolling pin from home. A lot of people, whenever they have that fascia, gets too tightly packed or not, it doesn't have enough nourishment in it, or it's not providing you with enough support. You can have some small tears in it, or maybe big tears, and that's whenever you get a lot of pain in the sole of your foot or bottom of your foot. And 9 times out of 10, your physical therapist is going to be like, okay, we got to knead it out. And so people at home, they will get out their good old either golf balls or rollers or whatever you got, and they'll go at it. So fascia, again, it is supposed to be loosely packed. Whenever we get that dense packed fascia, that's usually whenever we get in trouble because the fluid isn't able to go around in the tissue. Any questions there? If you hear my son in the background, I don't really know what's going on back there, but apologies. All right. So types of connective tissue continued. Let's talk about dense regular connective. So this is a protein fiber network in our ECM that is oriented prominently in one direction. So you see this picture right here on this slide. See how it kind of looks like squiggly lines, but they're also stacked one on top of each other like pancakes? There's not much extra room in there. So you don't see a lot of like blank spaces that might be filled with fluid. You just see like this. It just packed neatly. Neatly, that's a good thing to remember. It's neatly packed. But whenever we have this predominantly packed tissue that is going in one direction, it gives us a lot of strength. It doesn't give us a lot of movement because we don't have a lot of tissue going in different directions that we can play with. But it does give us a lot of strength. So it makes sense that this dense regular connective tissue would be what makes up our tendons, ligaments, bone, cartilage, and blood, but all these last two we're just not going to talk about right now. So whenever we think about our tendons, our ligaments, our bone, our cartilage, most of that, you don't want it to move very much, right? So you want it kind of tightly packed, not much extra fluid in there. This is important whenever we talk about tissues, because if we did have a lot of stuff in there, it's probably not a good thing. So let's break down tendons, shall we? Any questions? So tendons connect a muscle to a bone, like I was talking about earlier. I told you I sometimes get ahead of myself, apologies, but the more that you hear it, the better. The tendon connects that muscle to a bone for transfer of force for a movement. So again, we have that wadded tissue, so that thicker tissue that doesn't really have a lot of give. That's attaching the muscle, which does have more give and movement, to our bone, that's our lever. It has some ECM that, has the collagen, has elastin, ground substance, and then cells, very few fibroblasts. Now, do you see that last word down there? It says aponeurosis. It's a broad, flattened tendon. Has anybody ever heard of an aponeurosis before? I think that they're really cool, but I'm a nerd, so. This is basically whenever you take a tendon and then you stack it in with a buttload of other tendons. And that's a scientific name for it, buttload. But what it is basically a wad of tendons. So basically it gives you a beefy structure that you're able to have in your body. There are a bunch of different ones throughout the body, but one that you see a lot is in your hand. You see that picture right there where you have that tendon that splays out and goes over? You need that tensile strength and force whenever you are using your muscles, but you need that tendon in there to connect all those beautiful muscles that are up here into your digits. So that is important to know. Also, you'll see some other aponeurosis. The one that I deal a lot with women in my field is whenever we have a C-section and we have a scar that goes directly over the lower abdomen and they have cut through the aponeurosis that connects the rectus abdominis, transverse abdominis, and the obliques. And it's kind of a sad thing because that's an important junction where it's supposed to be nice and strong. Remember, I just said it's a wad of tendon to give us a lot of strength, but whenever we've cut through it, it kind of gives us some issues sometimes if we don't have it properly rehabbed. Any questions about that? Ligaments. So these ligaments, probably all of us have heard of the ACL, MCL, LCL, PCL. If you have watched a football game, you've probably seen somebody snap one of these bad boys. But it connects bone to bone for structural support, which makes sense, right, in the knee? because those are two bones coming together, and then they're supported by these ligaments, which again, they have less of the juicy stuff, more of the strength, right? Not as much pull or give, more support. Cartilage is a semi-vascular connective tissue composed of chondrocytes and various fibers that is found chiefly in the joints. We'll talk more about this, especially whenever we dive into the joints and the structures itself. Let's talk about the types of cartilage. So there are three types. The hyaline or articular cartilage is in the joint surfaces, the bony growth plates, those sort of things. Fibrocartilage, it has more of a higher quality for shock absorption. So that's where you find it in the menisci, the labrum, the pubic symphysis. Are we familiar with those terms? I can explain those out if we need them. Because I know some of us have not taken anatomy. So if you're giving like the deer in the headlights look, please let me know. Menisci are found in the knee. Labrums are found in the shoulder and hip joint, and we'll talk more about that later. And the pubic symphysis, and I have my hip model over there, is in the front of your body where the hip bones connect in the front. And then lastly, elastic. Higher concentration of elastin for that elasticity, and it's found in your ear, epiglottis, and tip of the nose. So if you look at your ear, it's nice and floppy, right? That's a good thing for where it's at, but you would not want that type of cartilage in your knee, right? You would really, really not want that type of cartilage in your knee. You need that higher collagen support for that shock absorption in the knee. Any questions about that? Again, these are just definitions that we're exposing you to now that you will need to have down religiously, especially by your human anatomy. Bone. Rigid body frame that supports body tissues, provides as a lever for movement. Remember me mentioning that word earlier whenever I discussed the tendon attaching the muscle to the bone? Provides protection, right? So think about the ribs, what's housed in our ribs, right? There's a lot of stuff going on in there. Our bones are actually protecting that stuff. Last one that I want you guys to focus on is it provides for storage of minerals. So that's whenever we talk about maybe eating disorders or different conditions where we start to leach away the minerals that are actually inside our bones, and we get more brittle bones and issues in there. So we need to make sure that we understand that there are actually important minerals that reside in our bones that act as kind of storage capacity, just in case, and keep them strong. All right, so bone continued. We do have ECM. We do have cells, and it makes sense that all those cells are osteo, right? Because we're dealing with bone. Again, break it down. You see those guys there. Let's talk about bone classification. So this kind of gets a little bit more applicable because now we can start thinking about the actual bones in the body. So I'm gonna move you guys out of the way. You're kind of in the way. There we go. Okay, so let's talk about shape. So we have long bones, which guess what? They are long. Don't overthink it. Examples are the femur, which is your big thigh bone that you got running from your hip down to your knee. Your tibia, radius, ulna. All these are long bones. These are found in the arms and the legs. Next up, short bones. They're approximately as wide as they are long. So the best way to think of this is all those little bitty bones in your wrist, the cuboid, in your feet, navicular, lunate, all these little bones, and you see that picture, it's the second one. So we got our long bone right here. We got these guys right here. See how they're kind of almost boxy? I say almost because nothing's perfectly boxy, right? But you do see how they have a little bit more of a precise shape. And then you have flat. So flat is exactly what it sounds like. It's broad and thin. This is seen in the skull. which makes sense, right? You got to have that guy strong, broad and thin to be able to cover our brain. And irregular, I always laugh at this one because basically if it doesn't fit into the top 3, guess what? It's irregular. So stuff like vertebra, the sphenoid. See, look at the T-spine vertebrae over here that we have at the very, very base. See how irregular that looks? That would not fit in any of the other classifications, correct? So it's irregular. Looks pretty funky. And if you break it down and you actually look at just a vertebra itself, you think, man, that looks kind of weird. How does that keep me upright? But all those little extensions and aspects of that bone are important, and they serve a purpose, which again brings back to the fact that the human body is amazing and it does everything for a reason. Let's talk about the long bone. So the anatomy of a long bone, you see the picture right here. So we have the ends, and then we have the center. The epi at the top, dia in the middle, epi at the bottom. Anybody ever heard of a growth plate? Yeah? Usually we hear about it whenever something's not right, correct? Like everything, we usually don't know that it's there until something's wrong with it. And then we're like, oh my goodness, I've heard of that. That's what's going on. Usually we hear about that whenever somebody is not growing appropriately, or if you see a fracture that goes into a growth plate, which is also very interesting. And I have an example of that whenever we get to the bones themselves. But there's an area in between where the dia and the epi meet, and this is where the bone growth actually occurs. And it occurs in that hyaline cartilage plate that we were talking about earlier. And whenever it gets all said and done, you're nice and tall, you've grown, whenever you hit that skeletal maturity, then it changes the name. And now it's a line. So instead of being a plate, it's a line. If you want to think of it that way, I used to think about it as you're growing, you eat a lot of food, so you have a plate. Whenever you're done growing, you hit a line. It's like not really the wall, but you are at your starting line after you have reached your maturity and grown all that you can. I always think about the guy who comes up to the buffet with like 50 different plates. And then suddenly there's that point where they're like, I can't eat 50 plates of food anymore because otherwise I will be 5,000 pounds. There's that line that you meet. Any questions so far? Okay. Y'all are quiet today. It's creeping me out. Okay. So the endosteum, we have a thin lining of cells on the inner surface of the bone. Periosteum, the thin lining of cells on the outer surface of the bone. The medullary cavity is the inner shaft of the bone that houses the bone marrow. Do you remember me mentioning about the bone marrow and collagen? So guess where we find a bunch of collagen is in that cavity. Let's talk about the types of bone. Spongy versus compact. Don't overthink it. Which one of those two pictures looks spongy to you? Like a sponge that you would find in your kitchen? Right? The top one. Exactly. It looks like a sponge would look like that's sitting on your kitchen sink. Hopefully not in muddy water, right? So you got the spongy bone, which is less compact. It allows for blood flow, allows for different things because of those spaces. So again, it serves a purpose. And then you have compact bone there on the bottom. And does that sucker not look compact? So it's a dense arrangement of bone. Now, whenever you start to break down these different components of a bone, I'm going to actually send you guys a great YouTube video over this because I love their graphics that they have and different things that they use to help break down the components of bone. Usually we do that on a whiteboard, but sadly, I do not have a whiteboard in the middle of my office. So we will not do that here. However, I'm going to send you a YouTube video that I actually prefer to even me drawing it out because I'm not an artist and they do a much better job. But let's break it down. So we have osteons. It's a circular longitudinal structure of compact bone. So remember, it's compact bone here. And as you break this down, if you look down at the bottom of my slide here, spongy and compact bone here, You see that osteon? This guy right here? Doesn't it, it looks exactly like the definition. It's a long circular structure. And it just, there's a bunch of them in this compact bone. Lamella is each cylindrical layer of bone matrix. Sorry, I'm clicking around here. Sorry, reading. Is one type of bone more prone to fractures versus the other? Great question. I'm trying to think of how, the best way to describe this. Can I answer that at the very end? Because we're going to break down some of the different components of the bone and it might actually answer your question. And we'll circle back around to it, I promise, Olivia, okay? Then we have these different canals that actually go through the bone. So again, it's like we're piecing away at this bone structure. Again, look at our beautiful picture over there. Do we see those canals that it's talking about? It's inside the osteon. It's pointing directly to it, but it's a little bitty central canal for blood vessels and nerves. So again, these canals house blood vessels and nerves. I want you to highlight that. That's a hint. But these specific canals house blood vessels and nerves. There's going to be another canal that we're going to break down next. I want to make sure that you guys separate the two. So let's skip down to Volkmann's canal. This guy was a central canal, right? The osteonic. It was a central canal for blood vessels and nerves. Now we skip down to Volkmann's. It's a horizontal canal that connects one osteonic canal to another. So do we see the difference between the two canals? Again, it'll make sense whenever I show you this video, and I will email that to you at the end of class. But one of them's actually housing the blood and the nerves, the other one's connecting those canals to each other. The periosteum, outer covering of fibrous connective tissues with blood vessels and nerves. These guys very small horizontal canals that connect one lochinae to another. Let's go back to this video, this thing, so that I can point it out. So, do we see these guys right here, pointing to this guy right there? Little bitty structure, and I'm sorry. But then we have these, I call them canals, because I think about what a canal does in the body. That helps you remember it. Please use it. If it doesn't, toss it in trash. I don't care. Won't hurt my feelings. But these canals are very small, and they connect these bigger areas to one another. So again, if this helps you piece together in your mind, please do. Whenever you see this video, it'll look all nice and pretty. But again, we have small chambers that house and they build. But then we also have canals that connect these houses and structures to each other. So again, the canals that we were talking about earlier, there's one that houses the blood and nerves. Then we have another one that connects those two. Well, same thing happens here with our small chamber. There's actually other canals that connect those as well. So everything's connected and it's all confusing. But whenever you see this in breakdown in that YouTube video, it'll really, really help piece things together. What I want you to think about those, especially for the exam, is there are some structures that actually house stuff. And then there are other structures that actually connect these, like highways or canals. They connect those structures that house things to each other. Any questions? Have I lost anybody or made anybody terribly confused? Okay, I hope not. So here's some embedded YouTube links. Let me know if they work. If they don't, let me know that too. I can send them an email. In the past, sometimes we've had some issues with it, so just please let me know. I do not mind sending. This will break down some different aspects of bone. And then I kind of like this one because this guy has a fun accent and he explains things beautifully, has some great visuals for y'all that I want you to check out. All right, so again, now we're breaking it down even more. So let's look at the inside. So now, we're kind of look at the bigger structures and how one thing connects to another. Now let's look on the inside of these guys. There's a lot going on. If you look at it there, you think of bones as like the dead thing. I don't want to say dead things, but the things that are hard, that the muscles do all the activity, they do all the work. There's all sorts of stuff going on inside the muscle, but we never really give it credit to the bone itself and that it is alive and that it has a lot of things going on in it. There's nerves, there's blood vessels, there's so much more. So let's talk about whenever we develop bone during growth and whatnot, injury as well. Ossification. So ossification is the process of bone development. That's a good thing to know. There are two types. And one is different than the other. However, sometimes they're seen together. And I want to make sure that I say this right because I always mess it up in my mind. So whenever we have endochondral ossification, it is responsible for the formation of long bones. So whenever we have this bone growth, the E1, if you want to, again, because I've tried to break this down as simple as I can because a lot of us have not had anatomy and we could get all nice and technical, but I understand if some of you, your brains are like exploding right now. But the endochondral ossification has to do with long bones. And I always think about, it's like a concrete pour. If you've ever been at a construction site where they usually have to dump the concrete in the center and then they spread it out, or in different areas and then they spread it out, that's kind of how that endochondral ossification works. It's more of a spot pour. Versus the intramembranous ossification is more like a tree. And you have a tree growth. It's seen in short and flat and irregular bones, and it occurs within a model. So there's already something almost like a framework already there that it goes by. And again, we'll break down the steps and it'll make a little bit more sense. And I will follow this up with a video because it always helps to see the process, okay? All these words, we'll be reading words, but again, pictures will be found in the YouTube link. So let's break down what happens in our short and flat bones, shall we? It occurs within this membrane model. The membrane itself actually develops. That's the first step, right? We got to have some sort of framework to deal with. So from the 8th week of development to about 2 years, so think way back when, and if you have kids, maybe you've seen this. From the 8th week of development until about 2 years, you're setting up this model, which is crazy to think about. And that's why kids are so Gumby. Thank goodness, right? Like their brains, like the long, or those flat bones, they're kind of squishy, or they look like cone heads and they kind of freak us out whenever they come out. They look like aliens, but that's because they're not as formed. There's not as that rigid structure there. That's because the membrane model is still forming. Then around 2, you start to see where maybe you start to experience fractures in little boys whenever they jump off the top of whatever they decided to kind of try to kill themselves on today. Speaking from experience, I have a 2-year-old. And so that's usually whenever we start to see maybe fractures occurring. Usually before then, they're so Gumby, there's not much going on. All right, so step 2. If you have any questions, stop me, okay? Just unmute yourself. Step 2. The POC is formed. So the cells in the center of this model, they specialize to osteoblast. Does anybody unmute yourself? What is an osteoblast? We know osteo. What does blast mean? I'll wait.
It eats stuff.
It what? So osteo is bone.
Oh, it makes. Yeah, it makes bone.
Yeah, and you would almost think blast. You're thinking like blowing stuff up, right? But it does. You're exactly right. So, which makes sense because that's what we're trying to do. We're trying to build bone, right? Begins to lay down the trabeculae to form spongy bone. Because remember, this intramembranous ossification actually creates spongy bone. So again, it's kind of like a tree. You might have the space, the area that's been cultivated for your tree, and now you're starting to send out the roots. All right, so step 3, We're getting there. The ossification occurs from the POC in an outer reaching like a circumnutical pattern. Think of it kind of like remodeling of the bone tissue creates an outer layer of compact bone around the spongy bone inside of it. So again, we have that model, and now we're starting to beef up that model. So we're just giving ourselves a little bit more security as we build the center. So if you want to think about it like this, that kind of helps. You can see me on the screen. Step 4, ossification continues until the entire membrane model is replaced by bony tissue. So instead of that membrane, now we have solid, right? Because we need that solid for protection. And this kind of goes into the fracture question, which we'll kind of answer as we go as well. But you want that instead of that membrane, which was kind of a little bit more givey, right? Now we have that bony tissue. It's harder. It gives us harder framework to work with. Then let's go into endo. So now this ossification actually occurs within a cartilage model. So it's not a membrane, it's within cartilage. And what type of cartilage did I mention it was within? Anybody remember? Make you guys start pulling in everything. Let's see who's paying attention. What type of cartilage was it? And bonus points if you can tell me what that cartilage does and what type of cartilage it is. You got notes probably. Oh, chat. Elastic, close. Did you look? I can go back and put it. It's way back there.
Hyaline.
Hyaline? Yeah.
Yeah, and what does it do?
The joint surface.
The joint surface, is that what you said?
Yeah, it covers the like the articulating ends of bones.
Yes. So wouldn't that make sense? If we're pouring into our cement mold here and we have cartilage that is creating that mold, it would make sense that it's at the ends of the bones, correct? And it would make sense that that's the same type of cartilage that in the future will be our supporting cush and provide a shock absorption. So it's actually already there. For the moment that you're starting to make these bones, that cartilage is already there. So remember my conversation last time about how cartilage is really strong? It's done a lot. It kind of gets a bad rap from us. It's actually been there from the beginning and actually helps us with this ossification process. But does that make sense to everybody? We just pulled in why it is that structure, why that cartilage would even be used, and then it's seen after as a function in the human body, especially at the knees. Does that make sense, everyone? Okay. Trying to apply what we're learning instead of just reading off definitions, y'all. That's really the goal here, is you got to start thinking about applying. So we have this cartilage model that forms. See here on the bottom, we have that model right there. And we'll refer back to this guy several times. Step 2, we have a lining that occurs and develops in the diaphysis. So in the actual shaft of the bone, we see it there. Do you see how it's that yellowing? Do we see that yellowing on both sides along the shaft of the bone? Right here. So again, we're getting a little bit more structure. I heard something that I didn't. So if you guys have a question, please let me know. Then cartilage in the diaphysis starts to break down and is replaced by bony tissue forming a POC. So remember, we had that cartilage model. It's seen on the ends of the bones, right, for shock absorption. So it makes sense that now we're replacing that with the bony structures in step 3 that we see right here. And we still have the cartilage at the ends, But here in the center where we're creating that long bone, we're actually starting to replace that cartilage with the stronger bony substance. Does it make sense? So now this is going to be our POC, where everything houses out of. And then, so remember my concrete pour analogy where like you have several different places where you kind of pour the concrete and then you spread it out? In step 4, we get a secondary ossification center. And those begin at each end of the bones. So we got the big guy in the middle. And instead of just pouring directly there, they actually give us 2 other sites. And those guys begin to lay down, and then they work towards the POC. So it's kind of like, here's your dot in the center, here's your dots at the end, and then they just start to converge together, building that bone, making it stronger in the process. And it speeds up the process. Does that make sense? Because if you're building a long bone, those guys are huge. Think about your femur. And if you were relying on and hoping that the center of your bone was going to produce all the things that you need, you're probably hoping and waiting for more than 2 years. So the body in its genius gives us 2 more sites at both ends, and then they just branch together and fill like a concrete pour in towards the center. Now, remember the plate that we were talking about? The area of cartilage at the end of each long bone between the POC and the SOC. So there's actually those plates. Remember how I said around maturity and after you've grown, they turn from plates into lines because we're done eating a lot and we've grown? This is what that's talking about. So whenever the POC and SOC finally merge and they get all the juiciness in there, you create the line instead of your plate. The plate growth continues to lay down cartilage and lengthen the overall length of the bone until we get to our max growth. Any questions on that? So now in step 5, so we had 1, 2, 3, 4, 5. The medullary cavity is formed in the diaphysis. So we can kind of see it starting here where blood's like trying to get in there to help us out. Then it gets a little bit bigger as the long bone grows. Then we really start it, it's formed, it's taken its shape in the 5th step. We see those discs at the very, very center with all that bony spread. Do we see how now it was, first it was like sparse, then bam, 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 and now even bigger? Again, giving us that advantage of having multiple different sites of bone growth. And as this medullary cavity gets bigger, has more transport, more things in it, that again expedites the process. Step 6, as the pace of growth at each ossification center is slightly faster than the place of new cartilage formation at the plate, the bone continues to lengthen, but eventually the plate is completely enclosed by bone and bone growth stops. So again, it's kind of like that line. The plate is there until you're done eating, you're done growing, and then it becomes that line. We're like, okay, this is as far as we go. This is as long as we get, and we stop growing. So, cement pour, long bone development, endochondral development. How do we feel about it? It's 6 steps. Got that nice little cartilaginous model. Then the diaphysis starts to get a little bit more structure. It starts to give you some bony material. It gives that strength in the long bone, the long portion of the bone. And then it starts to develop even more. We kind of see that cavity in the center start to get some blood flow, right? We see the POC established. 4th step, the secondaries come into play because they're helping us out from the ends. Remember, we still have the POC in the center, but the S's, they start kicking in and they're trying to, again, coming up and down on the long bone. Then we have number 5, where that cavity is fully formed, giving us a lot of beautiful blood flow, nutrients to the space. And then 6, where it just keeps on going until it overcomes that growth plate and becomes our epiline. Any questions? Now we get to talk about the fun stuff. So y'all are super quiet, which makes me nervous. But if I need to review anything, I will. At least in class, I can see the deer in the headlights look, so we can address, but it's a little bit hard virtual.
Are you going to want us to be able to define all of the steps, or, I mean, like each and every thing that's happening, or just know the matter of order that it happens?
Great question, Amanda. So in my exams, and we'll have review days, don't worry. So I'll kind of give you a framework of what you're dealing with. That way you're not sticker shocked. I will kind of have you put together the order of which this happens, like a matching where I give you all the steps and then you tell me what order it happens. That way it's not like you're trying to spell all these different words or you're not trying to figure out all the different names. You're actually just making the, no problem. You're actually just making the orders, the steps. Because really it's all about the concept, right? We're trying to apply the anatomy. I expect you in my class, and at my human anatomy class that I teach, I expect you to know the words. Now, they might not be spelled 100% correct, but I expect you to know the words, right? But in applied, we're more about the applied concepts. So we're taking these familiar anatomy terms, or unfamiliar for some of you guys, and then we're applying them. So here, ossification is applying it, it's growth. So we're taking these different structures. So really the concepts that I want you to know is how is it happening? Like how do we go from a jelly cartilaginous femur and now we have this solid bone that can help to leverage our movement. And Miss James, I love your dog. She's so cute. All right. I only see a few people at a time, but sometimes if they pop up, I'll be like, oh. Gives us a little bit more human interaction. So let's talk about bone trauma. This one's kind of fun, at least in my nerdy mind. So a bony contusion occurs as a result from a high velocity blunt force trauma. Makes sense, right? And this is to the actual bone tissue. So signs and symptoms, let's just break that down. Usually presents as especially painful, swollen, and limited movement in the area. Makes sense, right? You're not going to move it whenever it's got hurt. Just not going to happen. So treatment usually consists of ice to decrease that pain and swelling, and probably some padding, compression to limit the swelling and prevent future trauma. End results, a hard bony protuberance, a bump, usually develops in the area. So, you know, this is a bony contusion, and I'm trying to think, we could break down fractures next, but sometimes you can get a contusion to a bone that is actually so bad that the body responds kind of interestingly. It's almost like a self-defense mechanism. And if you go into this line of work where you're working with athletes especially, you'll find that there is a type, and I'll let you learn it later, but there's a type of contusion that if it gets so bad that the bone actually starts thinking, okay, I'm going to send help. I'm going to send osteoblasts in there, and we're going to start building some bone up. Because you've hurt it so much, we need to start repairing. And then it gets overzealous, and it actually sends a little bit too much. So it actually packs on a little bit too much bone, and you end up having problems because of that. So bony contusions can range from, okay, I hit my elbow on my funny bone, and ow, that hurt, and it felt really sore for a few days. Or I just had my father-in-law, he fell off of something, I don't really remember what, but he actually landed right here on that bony point of your elbow, which we'll break down later. That has a bursa right there, and man, that sucker swelled up and it was painful for a while, right? Or you could have a bruise in the center of your femur, and maybe you got hit with a helmet just straight on, and especially for maybe a thinner athlete, you're a little bit more exposed to the bone, not as much padding. You can actually have some permanent damage to that bone, even from a hit. So it can range from, okay, I have a purple, nice, pretty bruise, to uh-oh, where that purple, nice, pretty bruise is actually getting bigger and worse over time instead of better. So just things to think about. A lot of times we think about, oh, it's just a bruise. Oh, contusion, that just means a bruise. No, it could actually mean so much more. And I get excited about that, but it's not me being mean. It's just, it is really, really interesting. Types of fractures. So let's discuss this. So with fractures, it's a break in a bone. So you hear, you know, a lot of people, they don't know the word fracture. So like I, you know, fractured this. And they don't realize that that means a break in the bone, or vice versa, where they said, no, I broke it. And you're like, yes, that's what a fracture means. So sometimes there's a little bit of education that you have to give to your patient whenever they're not in the field that we are in. Types of fractures. So transverse fracture kind of makes sense with all of our other terminology that we've used with transverse. A fracture line that occurs perpendicular to the shaft of the bone. So you have your femur or your tibia, fibula, and you have a fracture right here, at level with the horizon. Oblique, that is a fracture line that is between vertical and horizontal. So it's literally like a slice. I think of like a sword cut. Spiral. So I give you some pretty pictures here to look at. You see how it's literally spiral, like you would see like a coil, how they wrap up. It's rotational and vertical in manner. So we see that bony point right here, and then the fracture actually spun down and ended down here. And you can see that on the other side as well. If you want to think about how you apply this, what would create this? Maybe the bone was weaker. So we talked about minerals, and I said that that was important, how the bone stores minerals. What if the weakest link always gives way first? What if we're dealing with an older patient or maybe a young girl who doesn't, or boy, who doesn't have strong bones? And so what gave first instead of at her knee? It was in her shin. And one of the bones, as they got that plant and twist, it was the bone that broke instead of at the ligaments and tendons. Again, it just kind of gets you thinking critically about the different terms and the different types of breaks even, is how would that happen? Oh, well, what if she had decreased minerals, decreased strength in the actual bone to where it was more susceptible than the tissue? And then we have this guy down here. So the commuted, it's a gunshot, right? You look at this either like a car wreck, a gunshot, where the bone is compressed and thereby in fragments. And you can only imagine the surgeon who's going to be amazing and going in there. And I know our sports med surgeon in the class, maybe this will be you someday, going in there, getting all those little bitty pieces out and fixing this man or woman and putting them back together. But do we see all those pretty little specks in there? All those specks are fragments of bone that used to be a structure. All right, so avulsion fractures. And I've seen these in person, and I was super proud of myself for diagnosing this correctly. Because sometimes, depending on the structure, it's kind of hard to tell. So avulsion fractures occur when either a tendon or a ligament pulls its bony attachment away from the shaft of the bone. So do we see right here on this picture where you see this floating where it shouldn't be floating? It's this white little piece. What comes in here, for those of you who've taken anatomy, comes down from the gastroc and inserts at the heel?
Achilles tendon.
Yes, exactly. And who knows, maybe this was a gentleman who was playing basketball. You know, there's that golden age in guys where you guys are more susceptible to Achilles tendon issues. And the actual bone was weaker than the tendon. So guess what? The tendon was all like, alrighty, bone, you're coming with me. And it takes the piece of bone off. It fractures that side, pulls the bone away from where it was at. I correctly diagnosed a soccer player at a tournament that I was covering. She had rolled her ankle. So it was literally, I got called over there and she's there over there holding an ankle. And you're thinking, okay, is it just a really, really bad ankle sprain? Like, what are we dealing with here? She drama queen, what are we dealing with? And so I start palpating around, and of course, it's going to start swelling. If any of you have ever rolled your ankle, you know exactly what I'm talking about. Goes into about the size of a softball and just like that. So I'm looking at it, I'm feeling around, and I feel a bump. Just right here. And I'm like, huh, well, that's not supposed to be there. And so instead of being like, okay, ice it, I want you to take a few days off, and you should be good to go, I actually sent her to the ER. Because whenever we have avulsions, we need to know it right then so we can schedule surgery, get it going, and get that tendon back where it should be, or ligament. And in this case, I was right. It was an avulsed. And I'm so proud of myself, I'm not gonna lie. There's some little things that you do in your life that you're like, oh my goodness, yes, win for Cassie. And this was one of them because these are really, really hard to diagnose. And so it was literally one of the lateral ligaments in the ankle. These guys are really, really little. And it had pulled off the bone. For some reason, that bone was weaker than the ligament and it avulsed right there. So that's why I make that big point of which one's stronger, the tissue or the bone. Next up, let's talk about stress fractures. We've all heard these if we know any runners. You know, maybe a cheer leader, gymnastics, a little bit there, yeah? And we'll see that. We'll see these stress fractures. Sorry, I was reading a chat. The stress fractures, they're like little microfractures in the bone. And it's just due to repetitive stress. So do we see that image right here at the base? See this dark spot right there? That should not be there. This would be like shin splints on steroids. So you know shin splints, they hurt, right? Now adding in actual deeper stress on the bone and more chronic stress applied onto the bone, that's whenever we start to get our stress fractures. They take a lot longer to heal and they are a lot more painful. Alrighty guys, wrapping up with some bone trauma, fracture healing. So again, this talks about the fracture. Whenever you have a fracture occur, your body responds, and it's brilliant in doing so, okay? So step one, we have a hematoma formation. Somebody tell me what a hematoma is. I know one of y'all know it.
Blood clot.
Mm-hmm. Kind of says a blow, right? So blood clot formation. Takes about a week. Blood clot forms and fills the area. And then our lovely little bone eaters come in. So osteoclasts come in there. They sweep away all the damage. They're like, okay, let's start fresh. So week one, we see this guy right here. Blood clot forms, helping us out. Next up, callus formation. So this takes about 1 to 2 weeks. Weeks 1 to 2, we'll probably see this. Fibroblasts. So remember fibro, remember blasts. Now stick them together. What do? So it's fibrin tissue.
Bone creator.
Exactly. So no, close. So fibro. So it's not bone. It's fiber. So it's that fibrin comes in first. And the chondroblasts. So now we're sitting in cartilage. So close mark. But look at the name. So fibro and chondroblasts. These guys come in first. And they form a mass about the perimeter of the hematoma to temporarily reconnect the two ends of the bones. So think of it this way. Whenever you have something broken at your house and you're not quite ready to fix it, what do? You slap duct tape on it if you're in Oklahoma, right? You're like, okay, this sucker will stay there for maybe another week until I can make it happen. And so you wrap it with about 14 layers of duct tape and you move on with what you can. Usually you're trying to save up some money maybe if it was a major break and something, I'm thinking of like a pipe maybe at home or something like that. So you're stacking away some money, but you had to put that first temporary fix on it. That's exactly what this soft callus does. It's the body being like, okay, we're going to give it this scaffold so that we can do the real dirty work. So that's what the fibroblasts and chondroblasts do. Because Mark, you're exactly right. The next up will be the bone coming in there and be like, okay, let's lay down the concrete cement. This is going to help us out for a while. But first, we kind of got to give it a little bit of a scaffold. Then we have the ossification. So remember ossification creating a bone, right? So the fibrocartilage is replaced. And external callus with spongy bone, and the spongy bone is then laid down in an external to internal fashion. So it kind of like creates, just like we were talking about, it creates that harder exterior, and then it works its way in. Then bone remodeling. So 4 to 8 weeks. It takes it a while, but bone is strong, right? It took you 2 years to get where you are now. Just imagine with rehealing a small fracture site. 8 weeks ain't too bad. Spongy bone is remodeled to form compact bone. So it's kind of like your duct tape. You put like a couple layers on there, then maybe you put a couple more, or you replaced it with something a little bit stronger because you need a little bit longer to get that money in check. And then at the very, very end, then you're like, okay, now we're going to replace the whole pipe. And so the spongy bone is kind of replaced and remodeled to form that compact bone, the stronger structure. The spongy bone did serve its purpose and it was great, but then it had to form that compact bone. Does that make sense, guys? Okay, again, give you another video. Check it out. It's a fracture site video. It'll help you out a lot. Emily asks, what is signaled in the body to start the body healing process for bone? How does the body know what to do for the bone? Great question. And you will learn this. Emily, remind me what you're going to do, if you don't mind. But you will probably learn this in your studies if I'm thinking who you are correctly, so forgive me. But the body has a bunch of chemical hormones and messengers in its capacity. So the body will actually send in different occupational therapy and yoga. Yes, right. So you will definitely learn this, especially for your older populations. So the body, which this is a great question. Thank you for asking that. The body will basically give signals. It'll send messengers and it'll be like, okay, this hormone responded with this, whether it was maybe inflammation process, which you'll get into later on, or whether it was a bone growth, or maybe both. And you're hoping that one shuts down sooner than the other. But as you're going through this process, the body will basically signal, okay, we want this one next. Okay, we want this one next. And in relation to your profession, Emily, and everybody else, think about what if you were working with an older population, or, I mean, if you were working with a younger population too, but with the older population in mind, think about how much slower your older populations heal. Right? They take a little bit longer, right? They take, the process isn't working as optimally or as fast. Typically that's due to hormones and messengers that are not working effectively, or chemicals that are not being sent appropriately. And so you're totally right. There is signals that are being sent out and communications that are going on in your body through the nervous tissue and so much more. And that's how the body knows what to do for the bone, because it is telling them. And so whenever we have that contusion that I was talking about, where it was a little bit too big of a contusion, it was a little bit too hard, and the body was like freaking out and responded, that was because the chemical messengers were like, oh, this isn't just a bruise. This isn't just a little bitty guy. We got to send more in there. We got to build on. We got to protect it. And it's not so much a faulty wiring as it is the body was just overly cautious and wanted to give you a little bit more support. So the body does send a buttload of different chemical messages, a buttload of different nervous system messages, neuromuscular messages to help you out with this rebuilding process. But it will vary depending on age, depending on location, depending on size of the fracture or hematoma, whatever the case might be. Does that answer your question, Emily? It's a long drawn out one, but hopefully it kind of gathered.
I have a question about that. I'm in human physiology right now. We're learning about the homeostasis loop. Would that be a homeostasis loop of like it's sent to the sensor, and that's part of the communication that determines like a negative or positive feedback kind of thing, I guess? I don't know. I'm just trying to.
No, you're totally.
Or is that part of
trying to relate?
different?
Yeah, I love how you're trying to relate. Good job. In a way, yes, because your body is trying to get back to homeostasis, correct? So it's saying it's a 1 or a 0. It's like, are we there yet or no? And then the body will tell you the other chemicals and other hormones that you haven't quite gotten to yet. You probably will in physiology, and you're going to love it. But there are other chemicals, other hormones that will be sent to let you know, hey, it's time for this, or hey, it's time for that. And whenever you get into, say, an immune system or inflammation response where the body has that histamine reaction and so much more, sometimes you can get too much of a good thing. And that's whenever we have to kind of come in and be like, okay, let's try to curb that inflammation process. Or let's try to mitigate how much it's trying to work for us, because maybe those signals aren't being sent effectively due to the damage in the body. And so, yes, the body is trying to fight for that homeostasis. And I kind of like how you brought that in, and I never really thought about that. But yes, it is the body trying to fight for homeostasis. Now, it's doing it in a little bit more of a complex way, but you are on the right track. Does that answer your question, Claire?
Yeah, all my classes are like forming together, and I was like, did I learn that from this
Yeah.
class or that class? I'm just not sure, but
No, and you guys will
I was
notice.
just going back to my notes,
Yeah.
and I just wanted to. Anyways, thank you. That did make
No.
sense.
That in what'll be really cool is whenever you guys start to learn about the immune system response or the inflammation response or Krebs cycle, different things that you wouldn't think would piece together and fit into things like this, but it totally does, because the body is amazing in how it works and everything's connected, which is a great thing, but can also be a frustrating thing. So as you guys go through your courses, yes, start to put those pieces together, because just because you're learning this in physiology, this in my class, this in anatomy, this in motor learning, a lot of these pieces will start to become a beautiful puzzle as you kind of start to connect the dots. And truthfully, I am still connecting dots from things that I learned 8 years ago. Like I've learned so much teaching human anatomy, and I've taken like 5 other human anatomy courses, plus extra certifications and more. But still, those little bitty connections you will find throughout your careers, throughout your education, that will start to link in. And that's whenever you know that you're thinking critically. So good for you, Claire. What other questions you got for me? Isn't the body kind of cool? Like, it's like, okay, so we got something going on. We have a fracture site. Let's give it a lot of hematoma. Give it a lot of bruising. Let's give it a lot of blood clotting to bring in a lot of nutrients. That's why it's doing that. And it's like, okay, got to give you a little bit of support as we start to heal. And it's like, okay, give you a little bit more support, a little bit more, and then we'll replace it with a full-blown thing. But it's letting you get all that nutrients, because what if it went straight from the hematoma week 1 to week 17 and beyond, hard callus, or hard, not hard callus, but actual hard bone, compact bone. What, if you think about what spongy bone does and why spongy bone is so important, because it has all those holes, what would happen? So again, think critically here.
The realignment wouldn't be as good.
Yes, very true. I like that, because instead of getting that scaffold and kind of steadily building it up, good point. What else? What does spongy bone do? What runs through spongy bone?
Nutrients and blood.
Yep. Exactly right, Amanda. So if you're not getting that nutrients, you're not getting that blood flow, you're not getting that into the structure, wouldn't it make sense that it wouldn't be able to get all the things that you would need as it's repairing? It's kind of like if you decided to replace your plumbing problem with, like, I'm going to be really silly here, but like a pool noodle instead of PVC pipe, because you were too broke and you couldn't wait, and you decided just to, okay, I have a pool noodle, we'll just replace it. Does that make sense? I know it's kind of goofy, but it would be like, okay, I'm just going to skip giving it all the love and giving it all the things that it needs and just go straight for it. So it probably wouldn't work as optimally, but instead the body in all of its wisdom gives you a little bit of extra time and the support that you need along the way. All right, you guys.
I've always kind of had a negative connotation with like blood clots. Like whenever I hear the word blood clot, I hear of it, doing damage. Is there any other difference in like is there something with the white blood cells, or is it just location?
Great question. Not quite sure how to answer that yet. So whenever you have blood clots, which you're exactly right, you're thinking like clotting like a thrombosis, correct? Or something where you find a blood clot in your calf and you don't want that to travel. Yeah, no, you're exactly right. So
it's just location then?
Yes, and components, because here your body sent that blood clot. Ooh, and you just, oh, I love where you just went. Because think about what if a blood clot from your fracture site traveled somewhere else, right? That's bad juju. You don't want that to happen. You want it to stay exactly where it is.
So it can even go bad when it's trying to heal.
Yes and no, because then look at weeks 2. You have a soft callus that forms. Again, containing all that stuff, giving you that structure. So again, the body's like giving you a little bit of support, helping to prevent that. But it also comes down to other medical conditions too. So it's not just, a fracture site. It could be what's going on in their blood pressure. It could be other things that are going on.
Okay. Yeah. So like if someone had like an issue with the thinness of their blood, that would also probably affect that.
Maybe.
Their ability to heal.
Yeah. Granted, I don't have a crystal ball, but yes, it would probably affect the healing. Every single body is different, which makes our job fun and aggravating at the same time, right? Because we can't know everything.
Well, we're talking about 2 different systems at the same time, too,
yes.
right?
Yes and no. And see, that's why I was having a hard time answering her question. Because in a way, no, but in a way, yes.
It's like skeletal system, and then we're talking about, she's talking about cardiovascular system.
Yes. But what is blood? It's a part of the cardiovascular.
Yeah, doesn't blood all come from or all pump from your heart at the end of the day?
No, it's created.
Now I'm confusing myself.
And see, that's why I don't want to break it down too much, because you're thinking along the right path. You're thinking about, well, we have blood clots in your skeletal system. Your blood is being pumped from your heart everywhere, right? So why not there? Why is it not connected? You're thinking along the right track. What Mark is saying.
But it's not connected. Or not connected how I'm thinking it's connected.
Yes. That's going to be my easy answer. And if somebody, because otherwise you're thinking
into it a different, like separate.
Yeah, because it's going to be different than what we're talking about here. And Mark, you're on point. It is 2 separate systems, but remember, everything's connected. Because you still have blood going everywhere. Blood is a part of the cardiovascular system.
Well, and blood is made in your bones, your bigger bones. So.
Yeah, and it's storing nutrients, and it's so yes and no. Which, Claire, I'm so sorry that you get like that wishy-washy answer, but it's one of those things where, yeah, you're dealing with 2 different systems. You're totally right, Mark, but they depend on each other. The heart would be exposed if it wasn't for the skeletal system. The skeletal system would not be able to build itself and maintain the nutrition and the structure that it has, integrity that it has, without the cardiovascular system. So it kind of goes back to my talk about their different classes, how it's going to be like this. Same rules apply in the body. You learn about systems, but you also have to understand that creates an organism. It creates you. So it does fit like this. We learn it like this, and then it starts to fold in like this. So long answer, Claire, you were right on track. You are getting the concepts. You will learn more specifics later, and that's not what this class is for. But I love how you're thinking that, because yes, blood clots. And I could go into a whole rant about how fracture sites and blood clotting and airplane rides and all sorts of things, but that's not what this class is for. However, I love the way that you're thinking, because you're now seeing the different systems and how they relate. And Mark, good job, because you're exactly right. Skeletal system is where things are housed, stored, formed. We even covered that in the definition of the function right at the beginning of class. So I love how you guys are thinking, because you're making me think. So go you. But you're totally right. Things do all connect together. And one thing will impact the other. And just because you went in for surgery, because think about surgeries, they always talk about risk for clotting, risk for other conditions. So start to think about that. You're applying all these different things. I love it. Does that answer your question, Claire? I know I'm like, yes, but no, but yes, it's.
No, it does. My classes are just like all like coming together, and it's confusing me a little bit, but because they're all like talking about similar things, but at different parts of the body, kind of like how you guys were just saying. So I'm all like, is that part of this or no? But I'll figure it out.
And our medical professionals here, Amanda, all of you, because I'm trying to think of the other names that I'm recognizing, Misty, the ones who are in, the field right now, if you have any pearls of wisdom as far as that I'm not articulating properly, please drop in, because this is where we all learn and we kind of associate those different parts. Because Claire, you're so right. We learn in different classes, right? We learn, this in anatomy, this in physiology, this in motor learning, this in da-da-da-da-da-da-da. And sometimes we don't think about, or it isn't addressed as well, because that's not the purpose of the class, how those things relate. And that you will glean over years of experience. And I'm speaking from experience because I'm still learning how all these things are related. But yeah, ladies and gentlemen, if you have any experience or words or things that you've learned, please let me know. Amanda says it will always be frustrating. Yeah,
that's good to know.
But it's not. And I will put the optimistic twist on there. Yes, it will always be frustrating, but you will always be amazed. There's not a day that goes by that I'm not amazed at some things that the women that I work with do. And I'm like, dude, you were left with that, yet you were able to do that. Or, how did, my mind's blown, how did you accomplish this? Or how did your body do that, even though you had this going on at the same time? It will blow your mind continually. And yes, it will be frustrating, because you'll be trying to just piece all those things together, and you'll remember something from 8 years ago that you're like, holy freaking crap, that actually applied to the real world. It's like algebra. You're like, oh, wow, I actually used that. Great conversation, y'all. This is what it's about, because we have to have these conversations. They're way better in person, because I usually put you through a few in-person examples that are kind of fun and silly, but you guys are making it work. I love it. Any other thoughts, questions? Amanda, and fascinating. Yep. So true. You guys made me think today. I love it. So looking at our syllabus, we've kind of bumped things up, which is a good thing, because what I kind of do is, if we get a lot of stuff done, I might give you guys a night off, especially say if it's before a holiday, because I want you guys to be able to have time with your family. But as we kind of tick through these things, like Claire was saying, if you have stuff from other classes that you're like, does this relate? Please bring it up, because that makes us all think critically, because we want to be able to apply what we are learning, right? This is anatomy and kinesiology. It's the marriage of all physiology, movement, motor learning, whatnot you are learning. So please bring it on. Chapter 4, let me pull her up here. Excuse me, I'm so sorry. Bones of the human body. So this will get fun. After that, we will probably be discussing some applied things. So stuff like heat illness, heat adaptation, acclimatization, that fun stuff. I'm taking a course from Dr. Cece Sims over those related topics, and so I might include some of that for you guys. But yeah, if you have any questions, hang around. Please email me your topics. Do not wait until the night before. Don't be that guy. Try not to procrastinate. Give me your topics for your journals. Give me your topic for your research papers. Email me your diagrams. Any questions before we head out?
I had a question.
Yes, sir.
I might have missed it, but when I was on Blackboard, I could not find the diagram to start on the assignment.
Okay, let me go. Thank you for pointing that out. I will pull it up real quick. Maybe. It's going to make me sign in, y'all. Just 1 second.
I just clicked content, and if you scroll down, they're below chapter 3 and chapter 4 PowerPoints. If that helps, they're a little bit further down.
Yeah, I'm going to pull it up.
Yeah. Anatomy of the pelvis diagram.
Yeah.
Yeah, so I just wanted to, and that's what I was going to do. So thanks for saying that. Here we are. Here's my view. Right here, you have the journal assignment breakdown. I added that to the top, so you guys should be able to see that now. That kind of gives you a breakdown of what in the world you're doing. If you have any questions or if you have any thoughts, if I need to add anything, please let me know. I gave you guys options on what type of formats you guys use, APA, all that stuff, just because I know everybody's at a different place in their educational path. So whatever you are more comfortable with, I've used them all. I don't mind. You'll see after chapter 3, chapter 4, you have the anatomy of vertebrae and pelvis. That's what you're looking at right there, sir.
Okay.
Here's what we're tackling next time. I went ahead and did minus school anatomy just because that can get a little bit too deep and intricate for what we want right now. You will learn that later on in anatomy. I'm not worried about that. You will have that. Plus, we'll be talking about concussions, which will be fun. We'll discuss all that stuff too. After chapter 4, we'll break down some fun applied topics related to what we've been discussing, like heat intolerance and maybe a concussion chat that I usually do with my coaches. And then we'll be ready for our first exam. So yeah, fun times out of bio. Any questions?
I have a question.
Yes, ma'am.
So for like the diagrams for like the anatomy of pelvis and the anatomy of the vertebrae,
Yes,
you
ma'am.
said if we like sent it to you and it was wrong, you would tell us what was wrong with it.
Yes, and I'll tell you, I'll be like, hey, look at this, this, and this.
Okay.
Like, really quite match up, or we'll discuss that, because sometimes people will find different words on the internet, and you're like, that's not quite right. But I usually don't get too picky with it as long as you're in the ballpark.
Okay. Cool. Thank you.
Yeah, and usually once I receive it, I know I have one in my inbox right now. I usually just, once I grade it, I just send you an email back and I'm like, hey, great job. You did awesome, 100%. Or, hey, let's take a look at this and this, rethink these, or have a discussion about why maybe we need to change those up a little bit. And then I'll give you that feedback after that too.
Okay, cool.
Yeah.
I see you're recording this Zoom.
Yeah.
Where do we find that on the content if I wanted to go back and watch it?
So what I'm going to do is I'm going to just basically put all the recordings at the very bottom. That way, because right now I have some of your PowerPoints hidden in view, so it doesn't look as claustrophobic as mine does. So basically all of your recordings that we do, I'll put them at the base. That does not mean that you get to skip class. Some people, they think that means that they can skip class. Does not mean that, because I do take attendance because Zoom is awesome. But just again, it's there that way you can go back through, maybe catch a couple of the mistakes that I made and point them out to me. I don't mind. But yeah, that way you can go back and rewatch them. And then also I'll be sending you those YouTube links at the end of class, so you have a little bit more to work with as well.
Okay, thank you. I missed the first part of class. I was getting an MRI and it ran late. So
nice.
With the sending topics, what was that about?
So
I can go back and watch it if you don't want to explain it.
Nope, because I want everybody to make sure that they do it. So remember the journal topics, you got 5 journal articles, you're doing 5 summaries. All 5 of those make a baby, and that is your research.
The research paper?
Yeah, so I want to know the topic that you'll be addressing this semester. So this fall.
And we're choosing that ourselves?
Yes.
Is there any guidelines for that, or is that
basically
on the breakdown?
Yeah, it is in the breakdown, I do believe, but basically it has to do with something that you were going into. So like your field, whether it's PT, AT, chiro, strength, whatever it might be, it has to do with the human body and applied in kinesiology. So thinking about the bones, thinking about the muscles, thinking about concussions, things of that nature. However, I don't want something so broad that you're like, I'm going to discuss physical therapy. Crickets, right? Like you're like, okay, what about physical therapy? Because there's a lot about physical therapy. You could break that down into, I want to discuss we have somebody who wants to own their business. I want to discuss the business of physical therapy, like the small business owners, things that they're seeing in that community. Or I want to talk about ACL return to play on soccer players, because there's going to be a buttload of research about that, right? And you're going to pick 5 articles and then compare and contrast them in your research paper later on. So you want to get something that's broad enough to where you have things to pick from. So that, again, that makes you actually think about your article topics. Think about what you're going to be doing before you send it to me. And I will let you know if I think that it's too specific. I want it to be related to your degree plan, your future goals as far as a profession. That way it's applicable in your life. Because remember, this is applied anatomy. I want you to get something out of it. Who would be able to recommend any topics for those who aren't specified in their degree? So Ms. James, do you mind refreshing my memory about what you want to do? What do you want to be whenever you grow up? I want to make sure, sorry, you sent me that private, but I want to make sure. You're not too sure. I love it. Give me something that you're interested in. Do you work out? Did you play any sports? Do you have a specific passion for, like, you're obsessed with Olympic weightlifting whenever we watch the Olympics, and hopefully they will happen someday soon? Do you love competitive swimming? Do you like synchronized swimming? I don't care. Whatever you pick and you park on that subject, dial in on something like an injury or the return to play or the mental load or something of that nature. That way it relates to you and your world wherever you are, and maybe what you future will do, because as you dig through the research, you might find some interesting things. But just find something that's relatable to the content that you see in this class, to the topics. Another good thing is to look at the topics of the chapters in our syllabus. So, we'll be talking about the head, we'll be talking about the legs, appendages, the applications there. That's a good place to start as well.
I have a question.
Yes, ma'am.
Did you say last week that we could use one that we've used from a previous class? Did you say that was okay?
Article, yes, but not paper, because remember the whole no plagiarism thing.
We can't plagiarize ourselves.
Yeah, sadly you cannot. However, I would love to see it. I would love to see what you do in their class. I don't want you to have to reinvent the wheel 14 billion times. I want you to, that's the politically correct way of saying this, repurpose that art.
Switch around the words.
Yeah, kinda. Like, just make it applicable to what we're discussing here. Sometimes you can have a journal article where you're just like summarizing it and you're just, talking about XYZ. I want you to point out the things that are going to be relatable to applied anatomy, to a sport, to a function, to your future career. Highlight those things in there as well. That way, again, it makes it a little bit more specific and avoids that plagiarism as well. That makes sense.
I have a question.
Yes, ma'am.
Okay, so I'm going to school to be an exercise physiologist.
Sweet.
And we're just like a topic. So not a like topic of like career on an exercise physiologist, because
that's super broad, right? Like,
yeah.
Y'all are seen everywhere. So where would you park your bus? Like, where, in your career field, where do you want to be seen? Do you want to be in a hospital? Do you want to be in a physical therapy clinic? What are the problems that you would be tackling? Like, would you be working with athletes? Would you be working with yada, yada, yada? It doesn't, you guys are kind of overthinking it, but give it to me give me your ideas, email it to me, and I'll tell you if it's too broad or not.
Okay.
No,
so our research paper is going to be over whatever 5 articles, or the research paper is going to be, our question that we're researching is going to have 5 different articles that we've written summaries on that go with that topic?
So I'll say it in my way, and maybe it's the same thing that you're saying. You guys are picking 5 articles for me. And why I'm making you guys do this is because it is a little bit more complex because it's applied. That's the frustrating thing for everybody, because instead of being like, okay, I'm going to tell you exactly what I want you to research, it's a little bit easier that way. So I'm making you guys think. So thank you for asking this question. I'm making you guys find 5 articles over the same topic. So whether that is concussions, whether that is exercise physiologists working with, I'm trying to think of something, post-rehab to return to play, or post-surgical patients, or maybe diabetic population, something focused in wherever you kind of see yourself going. Whatever you pick. So I'm going to use ACL female return to play in soccer. You're going to find a buttload of research on that, by the way. It doesn't even have to be sex specific. So it could be females and males. It could just be ACL return to play, soccer. You're going to find 5 articles over that. Now, there'll be different things. So it'll be like the long jump test compared to the strength in their quads and their hamstrings, the ratio there, compared to the chances of re-tear. But you have to forward think. This is the apply part that kind of gets everybody, is you have to think about, okay, critically examine these 5 articles that I'm going to be writing my research article over later. How do these things fit together? What similarities do I see? What things do I not see? Am I seeing no similarities and it confuses me? Tell me that too. I want to know, is this helping you further your education, further your experience, further your knowledge in that specific area to where you can start to see how these things are applied together and come together, how they compare, how they contrast, and how they will actually help you be a better professional in your field? That's what I want to see. I want to see you guys think critically, which is the hardest part of college. Sorry, not sorry. It's where you have to take that eye and you kind of have to step back and you look at your articles and you go, okay, so what's going on in these articles? I read it once, kind of skimmed through it. Do I actually know what I just read? That's basically what I'm asking you. Do you know what you just read in these 5 articles? Can you compare and contrast them? Is there anything in there that you're like, okay, wow, I can take this into my field. Let me know that. That's what I want you to do with those articles. Does that answer your question, Claire?
Yes. How long do those need to be then if it's a summary?
1 to 2 pages. I put that in the breakdown.
Okay. Okay.
Great question. Your research paper will probably be 3 to 5 pages. Somewhere around there. It's not like you're writing me a book. You're just comparing.
I see it. Sorry. I'm like,
you're good.
I've pulled up and I'm like, where is it?
No worries. How do we feel? Okay. Any other questions, you guys? Emily, I'm not sure if you did email it to me because it's not pulling up on here. All right. If that is it, you guys are free to go. Thank you so much for your participation, for the conversation, for making me think, for making each other think. This is what this class is about. It's to challenge your brains, make you associate, even if you're not familiar with all the little bitty words in anatomy, that's okay. This is where you start applying and understanding those concepts and terms. If you have any questions, please email me. If you have any questions that you would like for me to address today, just hang around and I will stay here kind of after class for any questions that I can answer. And yeah, have a fantastic Tuesday night, you guys. We'll see you next week. Be looking.
Thank you.
Bye. Olivia, Dakota, any questions?
Yeah, so last week
Okay.
I had mentioned the topic for my article.
Yeah.
I'm kind of having trouble like finding the right research online because a lot of it is kind of like quote unquote bro science stuff.
Mm-hmm.
So it's like I can.
Remind me of your topic again, because I remember that we had the conversation.
We were talking about just injuries in the sport of powerlifting.
Yeah. And I love that topic. So yeah, you're right. Bro science. That's where it's
Yeah.
at. Yeah. So now let's think about it. So what were you finding exactly? Were you finding any research articles? What terms were you using for your research? What were we given?
I'm sorry. What was that?
Like as far as were you searching Google Scholar? Were you searching PubMed? Where were you going for?
I was just on Google at first. I haven't
Okay,
gone.
I want you to go to Google Scholar, put in powerlifting, injuries, see what comes up. After you do that, you'll probably get a buttload of research articles. Make sure that you go to the side and actually search for research journal articles. Excuse me, only. You can actually just select that because that'll kind of narrow down your search to those published peer-reviewed articles. That's what we're looking for.
And you said do that on Google?
Yeah, just Google Scholar. So you're on Google and just type in Google Scholar and it'll come up, go there. That'll give you access to a bunch of different stuff.
Okay.
And then you can go into TCC Library. If you have not done that, and that'll get you access. Make sure that you're signed into the library and that'll give you access to a lot of those articles. Because some of them are free, which we like free. Some of them they'll lock down and they're like, no, you don't have access to this. Usually if you go through the TCC library and you put in the title of your article, you'll see it pop up.
Okay.
Yeah.
So as far as like pulling information from my articles, do you want me to just like narrow it down to like the most common injuries, or can I like add on to it, like aside from that, like the recovery time, the differences between male and female injuries, like
Yeah, and that's the cool thing about the summaries, because you can give me all that in the summaries, and then the research article you can be like, okay, I found these similarities in the injuries, like what was going on actually, and then I also found like the recovery times, they seem different for this and this. Here's how I'm going to use it, because if I'm going into that field or I'm really interested in that, now I know that if I'm working with this part of the body or this type of injury, it's going to take us a lot more time than compared to XYZ. Or like you said, sex differences. Did the males return to play faster than the females? Was there injury reoccurrence? You have so many different ways that you can go with this. I think that that's the struggle with this assignment, is because you kind of get that deer in the headlights look and you're like, I have so much information, where do I go with it? But it's just more of filtering it down and focusing in on what is interesting to you, because what you're interesting is probably going to be different than what I find interesting. And I probably glanced over it and I missed it, but you pulling it to my attention and to everybody else's attention will again educate us and kind of be like, oh, I didn't even think about it that way. Does that make sense?
Yeah.
Okay. No, I love that. I love the topic, and thanks for reminding me, because it'll dive in. It'll be really cool. I can't wait to see what you come up with. But try Google Scholar. If you find titles, maybe copy paste them over into TCC Library, that search bar. Plug them in there, see if they pull up, and then you'll definitely be able to find 5 articles. If you don't, email me, let me know, because we'll fix this problem before next session.
And you also said look at PubMed.
Yeah, so Google Scholar should give you a little bit of that, but yes, look up PubMed. You should have access through TCC to PubMed, so you could probably go into this TCC library, search bar, PubMed, click on that. It should be able to bring you in. That's another place where you can, again, search your key terms, powerlifting, injuries, male, female, whatever demographics or things that your criteria that you're looking for, that's where you can plug that in.
Okay.
All righty. Well, let me know if you have any problems, just email me, okay?
Okay.
Okay. Have a great night.
Thank you too.
All right, Olivia, I'm guessing that you left. So if you need me for anything, let me know, okay?